Well, today we're going to have a lesson that I like to call, is it exponential or is it linear? Let the battle begin. Let's start by talking a little bit about linear equations because that's the one we're most familiar with. Linear equations, you're probably remembering from algebra, y equals mx plus b, where m is the slope and b we often refer to as the y-intercept. In reality, when we're talking about applications, m, the slope, is actually known as the growth rate. It's how much things increase with each increment. B, the initial value, is something you might not be used to hearing that called. You're used to it being called the y-intercept. Initial value, when x is 0, that's what y equals. Now, what we're looking at is exponential functions. Exponential functions, if I look at it in the same vein, I've got c will be a number, a will be a number, and my exponent is an x. A little bit different than a linear one where we didn't have any exponents. A is known as my growth factor, similar to when I said m, the slope, was my growth rate. C, that number out in front, that number has no exponent, very similar to B, that didn't have any x with it. That's our initial value. In other words, when x equals 0, what does y equal? So let's take a look, and this is where your notes are going to come in. Let's compare and contrast these two equations. One of them is linear, one of them is exponential. One way to take a look at comparing and contrasting them is to fill in some tables of values and see what's going on. So I'm going to fill in the same values for each of these. I'm going to choose a negative, a 0, a 1, a 2, a 3. I want to see how y values change. Now with this first one, 16 times 1/2 to the x. If I put a negative 1 where the x is, I have 16 times 1/2 to the negative 1. Remember what a negative exponent does? It takes that 1/2 and flips it, so that's really like 16 times 2, or 2 over 1. That equals 32. If I put a 0 where that x is, I'll have 16 times 1/2 to the 0 power. Any number to the 0 power is 1. 16 times 1 is 16. If I put a 1 where that x is, I'll have 16 times 1/2 to the 1 power. 1/2 to the 1 power is just 1/2. What's half of 16? It's 8. If I put a 2 where that x is, I will have 16 times 1/2 squared. Well, what's 1/2 squared? 1 squared is 1. 2 squared is 4. What's 16 times a fourth? A fourth of 16 is 4. So the point 24 would be on the graph of that equation. If I put a 3 in there, I'll have 1/2 to the 3rd power. So again, I'm going to do 16 times. 1 to the 3rd power is 1. 2 to the 3rd power is 8. 2 times 2 times 2. What's 1/8 of 16? 2. So what's going on here? If I take a look, my y values start at 32, go to 16, go to 8, go to 4, go to 2. Can you predict what the next one would be if I put a 16 times 1/2 to the 4th? Sure, it's going to be 1, because what's happening each time? These values are being cut in half each time. So we're going to write that in words. Y values are halved in each increment. Okay, an increment is just in each step. So y values are halved. Um, let's see what happens now. I'm going to grab this stuff and I'm just going to give myself room to write here. I've got the same x values that I had for my first equation, but now I've got a totally different equation to mess with. So let's see what happens here. If I put a -1 where that x is, I'll have 1/2 times -1 plus 16. Isn't that just -1/2 plus 16? So what is that? That's 15.5, because that's the same thing as 16 minus a half. If I put a 0 up there, I'll have 1/2 times 0 plus 16. 1/2 times 0 is always 0. That just equals 16. If I put a 1 up here where that x is, 1/2 times 1, that's a half, plus 16. 16.5. Are you seeing a pattern? Let's put a 2 where that x is. 1/2 times 2, oh, that's just equal to 1, plus 16, I get 17. How about 1/2 times 3, that's 1.5, plus 16, 17.5. In words, can you tell me what's going on with those y values? In words, those y values, where can I write this? I'm going to get rid of my work here. In words, here my y values increase by 1/2 in each increment, in each step, if you will. So now if you think about what we just talked about, when I gave you these descriptions for the linear function, I said m was a growth rate. If m is a growth rate, here's m. Here's m. That number is our growth rate. We're increasing. Each of these increases by a half with each increment, with each step. B, this value, which is 16 in this case, that's what happens when x is 0. When x is 0, I got 16 for y. That's what I'm talking about when I say that's my initial value. If we take a look at what's happening with my exponential model, something very similar is happening. Here, if I compare that to my equation, y equals ca to the x, c is 16, c is my initial value when x is 0. When x is 0, I got 16 for y, just like I was supposed to. This number, a, is a half, and that's my growth factor. That's what's happening. What am I multiplying by? In other words, 32 times a half, 16 times a half, 8 times a half, 4 times a half. Each time I'm multiplying by a half. Remember, multiplying by a fraction is the same as dividing by its reciprocal, so divide by 2 would mean the same thing. At this point, you should have no problem, if you have no questions on this, you should very easily be able to do numbers 21 to 28 on the next assignment. This is what it refers to. Let me know in class if you have any questions. Thanks.